My name is Matt Amthor, and I'm working at GANIL now, which is the Grand Accélérateur National d'Ion-Lourdes, which is the big heavy ion physics laboratory in France. And they're in the midst of working on a major upgrade to compete with the new Japanese upgrade and the prospective one here at FRIB. And so I'm working on the design for the next generation super separator spectrometer. The design of the spectrometer, of course, will have an impact on a lot of different areas because the whole goal of this particular system is to be usable in a variety of running modes. So you have a lot of recoil spectrometers, so I'm getting a little technical, I guess, but a lot of times you build them for a specific purpose. So there are several that are very geared toward only astrophysics. In our case, we want to be able to do the astrophysics experiments like they do at Notre Dame or at Triumph in Canada, but also to do some other types of experiments like the super heavy element synthesis, discovering new heavy elements on the top of the chart of the elements, and all kinds of other things in between. When I got into nuclear physics as a student, especially starting into grad school, I think I and a lot of people, you have the worry that, what am I going to do? Am I going to have enough work to have a career? Am I going to have ideas for publications? And once you really get into it and you start reading the papers and the literature out there, you really realize the problem is exactly the opposite, that there's so many things to do and they're all interesting, and there just aren't enough people to do it. Since my dissertation work, which I finished in December, I was working on models of type 1 X-ray bursts, and also I finished an experiment to study some of the reaction rates that take place in these explosive burning scenarios. So there's a lot of work to be done on both sides, both on the reaction rates, which determine exactly what happens, and right now they're really unconstrained because they all take place on these rare isotopes. So up until the latest facility, it's been really difficult to measure them. Some of them can't even be measured. And then on the other side, once you get the better rates, you have to be able to build that into a consistent model that treats the neutron star structure. And that's another thing that has to be done. But the only way to do them really is together, because if you can't constrain the nuclear physics, then you can never hope to tell whether your model is even close to correct or not. I came to the 2009 NSCL User Workshop just hoping to reconnect with some people here, finish up on some experimental work that I had done last year, and get started maybe on some new projects also, because there's always some upgrades taking place. As you know, I guess the reaccelerator is being built, 2 stages, and then they're always planning the next thing. They want to say, okay, well, what do you want to do with the next thing? Or what next thing should we even build? Do we need a high resolution spectrograph? Do we need a high acceptance spectrograph? And you really have to think very carefully about what kind of experiments can I do? And that's where the users come in. We have to figure out what's the most exciting science and decide together what next steps to take.